Our group consists of Anis Suraya, Nur Syaukina, Hafizullah, Nur Fasihatul Husna, and Sharifah Kalisa.
First of all is the introductions. For this task, we will be performing data preparations or data pre-processing, which is the process to gather, combine, and organize the data. This task will include data cleaning, reductions, and transformation. Data preparations purposes is to make sure that the data we choose will be accurate and consistent. This is because data is common with missing values, inaccurate, or even a lot of errors. Therefore, correcting the data will be needed for the process of this task. First, for data cleaning, we will be removing incorrect, incomplete, and inaccurate data. We will also replace the missing values. Next, for data transformations, data will be converted from one format to a different format, which is the required format to continue the data mining objectives. Lastly, we will be doing data reductions, where we will reduce the data set and obtain a much smaller data in volume, but closely maintain the integrity of the original data. This is the data preparations process that we will be doing throughout the task. The problem statement is to predict if a customer will take the coupon given under a particular venue by considering their demographic and appropriate attributes. The objective is to understand the customer's response to the recommendations made in vehicle recommender system that will provide coupons for local businesses.
Data understanding. This data, which is in vehicle coupon recommendation, was downloaded from UCI Machine Learning Repository, which is the website for machine learning and intelligence system. This data is based on a survey that was conducted on Amazon Mechanical Turks towards drivers from different scenarios and whether he or she will accept the given coupon. This data was used in an article in 2017, which is a Bayesian framework for learning rule sets for interpretable classification. The data consists of 23 attributes consisting of nominal and numeric attributes, 12685 instances, and this data also has a missing value. Moving on to article description. The name of the article is a Bayesian framework for learning rules set for interpretable classification. This study was conducted by Wang, Tong, Cynthia Rudin, Fina Ledoshi-Velas, Yimin Liu, Erika Klumpf, and Perry McNeil. This article is in the Journal of Machine Learning Research 18, number 1, year 2017, page 2357 to 2393. This article studies for machine learning algorithms to build classifiers that are compromised on a small numbers of short rules. The models of this form have the advantage to be interpreted by human experts. Bayesian rule sets (BRS) used to characterize and predict users' behavior with respect to the in-vehicle context-aware recommender system.
Assalamualaikum everyone. Today I'm going to show how we actually do the cleaning process for this dataset. This dataset uses classification method and consists of nominal and numeric type of data only. So first, we want to study the numeric attribute in this dataset and find the minimum, maximum, mean, and its standard deviation. So now we choose one attribute with numeric type. For example, we choose attribute to coupon GEQ 5 means. Here, tada! Now we can see the minimum, maximum, mean, and its standard deviation value. Next, study the value and the count for each attribute of nominal type attribute. Choose one attribute with nominal type. For example, we choose attribute destination. And now we can see this is the value and this is the count for each value. Moving on to the next, which is we want to identify the missing value and how to remove the missing value. Let's say we choose attribute bar. We can see the missing value is 64, which is 1%. So what we're gonna do is click button choose, filter, unsupervised, attribute, click replace missing value and click apply. So now we can see the missing value are gone. The purpose of removing the missing value is we want to get the very best performance. Next, identify the attribute containing noise. As you can see here, we have something like unreadable data, and this is the noise data in this dataset. What we're gonna do with this noise data is, first, save into CSV and open in the Excel. So we want to replace this unreadable data, which is last one, and GT8 into readable data. What we need to do is highlight this column, press Ctrl F, find last one, find all, and click replace. Replace with less than 1. Replace all. Repeat the same procedure for GT8 and replace with more than 8. Now we are done. Save the Excel and upload into Eka. Now we can see all the noise data have been replaced into readable data. Another noisy data is the extreme value. Highlight the extreme value column, Ctrl F, find yes, find all, Ctrl A, and click delete. Next, the last part is we want to determine whether this data set consists of outlier or not. What we need to do is click choose, filter, unsupervised, attribute, and find in the quota range function. Click apply. Now we can see the new attribute, which is outlier and extreme value. Click outlier. So in this data set, we have no outlier. So that's all from me. Thank you.
Moving on to data transformation. Data transformation involves normalization, discretization, and attribute construction. Normalization used to get rid number of anomalies. These anomalies make the process of analysis the data more complicated. Hence, we need to get rid of anomalies. This method will convert huge number data to smaller value. Usually, numeric attributes need to be normalized by using min-max normalization, z-score normalization, and decimal normalization. For our dataset, we use min-max normalization to normalize the data. So, how to perform this task? For our dataset, we apply the normalization filter for attribute temperature since this attribute have huge value. First, we go to filter, then go to unsupervised. Click attribute and then choose normalize. Set the translation, which is the min value, to 0 and scale the max value to 1. Then click OK and apply. As we can see, after applying the normalization filter, our data has transformed to a decimal value between 0, which is the minimum value, and 1, the maximum value. Discretization is transforming numeric attributes to nominal. This method also used to divide range of continuous attributes into intervals. For example, values for numerical attributes like temperatures may be mapped to below 33 Fahrenheit and 67 Fahrenheit and above. We apply the discretization filter by click the choose button for the filter. Then select unsupervised, then go to attribute, then click discretize. For our dataset, we set the bin range precision equal to 6 and bins equal to 3. Then click apply. Now we can see our data have transformed to nominal attribute. After applying the discretization filter, we name and label the temperature attribute. First, we save the data as CSV file. Next, open the data in Excel. Then click our temperature attribute at the D column. Click Find and Select, or simply just press Ctrl F on the keyboard and choose the Replace tab. On the Replace, click Find What and type value -INF 0.33. Replace this value with below 33 Fahrenheit. Then click Replace All. Repeat the same step for 0.667 INF to 67 Fahrenheit and above. This is the result after we label the data for attribute temperature. In attribute construction, new attributes are constructed from the given attributes and added. This filter functions to improve the accuracy and understanding of structure in high-dimensional data. method, we do not change the data or add new data. We just transform the existing data in more understandable and presentable form. Example, we may wish to add the attributes area based on the data transformation attribute height and width. For our dataset, we did not apply the attribute construction as there is no attribute that can be applied the data transformation operation to create a new attribute.
How exactly do we develop the model from our data and evaluate them? We could use classification or clustering. This slide shows you the comparison between those two methods mentioned. For our group project, we will use classification by applying J48 algorithm. So we will see in terms of cross-validation and percentage split. Before we start our classification process, we need to make sure that we have two types of data. The first one is training data and the second one is testing data. I will take the data that my friend before this, Anis and Shaukina, has prepared. You will go to the last attribute of the data and you can see the class label right here. Delete all the class label because we want to do a testing data set. So we will take this and just delete it. Rename it back because we deleted the title. And then we will save it in a CSV format. And also we will rename it testing data. Okay, just save it. After we have prepared the testing dataset, we will start our model development process. So first, you need to load the training dataset into the Weka Explorer. Next, you will go to the Classify tab and click Choose. And then go to the trees and select J48 since we wanted to use J48 algorithm. In our group project question, we are required to do the cross-validation of k equal to 10 and k equal to 20. First, we will perform the k equal to 10 or 10 folds cross-validation. We need to type 10 here, meaning that the dataset will be divided into 10 parts. Then we click the Start button. On the right panel, Weka will give us the analysis of the data. We can also see the accuracy in this right panel, which is provided here. Correctly classified instances is 74.64%. They also provide incorrectly classified instances percentage, which in this case is 25.36%. So now we know that the cross-validation of k equal to 10 produced the accuracy of 74.64%. Now we have construct the learn model based on the k equal to 10 folds. Next, you need to save the model. Next, we need to right click at the J48 and load the model we have saved just now. And then we clicked on the supplied test set and click the Start button and click the Open File button. Now you need to upload your testing dataset. Next, click to the More options and untick all of the settings. Choose Output Prediction as plain text. Next, you need to right click here and select Re-evaluate model on current test set. So this is the result based on the prediction. So this is the prediction starting from instance number 1 until instance number 110. For example, in the first instance, the predicted class label is 1. For cross-validation of 20, you just repeat the earlier steps and just change the folds to 20. So now that we know the cross-validation of k equals to 20 produces 74.3% accuracy. This is the prediction together with the number of leaves and size of tree. The question of our group project asks to generate the tree visualizer of the best result. Comparing both k equal to 10 and k equal to 20, we can conclude that k equal to 10 cross-validation produces more accuracy. So we decided to generate the tree visualizer of k equal to 10. First, you have to right click in here and select Visualize Tree. The tree will pop up. Click Fit to Screen. You will get the result of this. From this tree, we know that the attribute coupon is the root node. For percentage split, we will still do the same thing and still use the J48 algorithm, but the only thing that is different is the selection of the test option. We will choose the percentage split over the cross-validation. So let's do the 70% percentage split first. So we need to type here 70% and click Start. So the accuracy of 70% percentage split is 73.266%. This is the prediction together with the number of leaves and size of tree. For 80% percentage split, just change the percentage to 80 and click Start. We will get the accuracy of the 80% percentage split, which is 72%. This is the prediction together with the number of leaves and size of tree. Comparing the percentage split of 70% and 80%, we can conclude that percentage split of 70% produced a higher accuracy, and that's why we choose percentage split of 70% to generate our tree.
Okay, now we are going to the next step of the data preprocessing, which is the data reduction. So the aim of data reduction is we want to reduce the size of our data sets, but we want to minimize the loss of the information content. Okay, so first we are going to select attributes, and then we choose attribute evaluator, and then we choose this, which is info gain attribute eval, and then click yes, and then make sure it's ranked T here, and then click start. Okay, from here we can see all the rank of our attributes. So starting from 0 to 0.7, which is the Weka will rank our attributes from the most used and not really use all the attributes in our data set. Okay, so now we back to preprocess. Back to preprocess tab. Here we are going to choose any attributes that doesn't really interfere with our data. So remember, the aim of data reduction is we want to reduce the size of our data, but we want to minimize the loss of information content. So here we can remove the attribute that we don't want based on the based on the paper of our data set, or anything that we see doesn't really interfere with our data. So let's say for the example, in my case, I'm going to remove destination, weather, temperature, time, gender, marital status, has children, has education and occupation, and also car, following by direction same, direction OPP, and then outlier and extreme value. So after choosing all these attributes, I'm going to click remove, and then here it is. These are only the attributes that we are going to use in our data set that we have reduced in the data reduction. That's all.
This is the comparison between full dataset and reduced dataset. It is shown that full dataset and reduced dataset have differences in percentage of accuracy. First, for cross-validation tenfold, full dataset have 74.64% of accuracy, but decreased to 73.32% in the reduced dataset. Then, for the cross-validation 20-fold, full dataset has 74.3% and decreased to 72.94% in reduced dataset. After that, percentage split 70%. Full dataset is 73.27%, but reduced dataset have 72.2%. Lastly, for the percentage split 80%, it is shown that full dataset have 72%, but reduced dataset have 70.9%. This comparison shows that the full dataset have pretty much higher percentage of accuracy than the reduced dataset.